In this video, we're going to get a couple more definitions that we're going to use to prove some more theorems, and they're actually concepts that you saw back in Math 225, divisibility and congruence. So first, we're going to review what the definition of divisibility is. We're going to review the definition of congruence, and then we're going to look at some examples. So as with most concepts in this class, I usually have a model, a more concrete model to help us understand these concepts. And the model we're going to use in this one is not terribly creative. I just call it the no remainder model for divisibility. So if we say that m divides n, that means we can divide m into n, or we can do the problem n divided by m, and you get no remainder. It divides evenly. Another way of writing m divides n is to write m into n with m first, n second, and then a vertical line in between them. So for instance, we have 12 divided by 4 is equal to 3 with no remainder. We also have 12 divided by 6 is equal to 2 with no remainder. And that tells us that 4 divides 12, since 12 divided by 4 is 3, and 6 divided 12 as well. So that's because 12 divided by 6 is equal to 2. Which is a whole number. So we can also say this in a different way, and it turns out this way is a little bit more convenient, especially when we're using this concept in proofs. We can also say 4 divides 12 because 4 times 3 is equal to 12, and 3 is an integer. And we can say that 6 divides evenly into 12 because 6 times 2 is equal to 12, and 2 is an integer. So we can write this notion of divisibility in terms of multiplication. Now, just note that it is not true that 5 divides evenly into 12, because when we divide 5 into 12, or 12 divided by 5, we get a remainder of 2, which is not 0. Alright, so here's our official definition of what divisibility is. So let m and n be integers. We say that m divides n if n is equal to mk for some k in the integers. Notice that n is the second one in the m divides n, and then m is the first one. They're kind of written in the opposite order when we write our equation. There are lots of other ways of saying this. We could say n is divisible by m. We could say m is a divisor of n. We can say m is a factor of n. And we can say that n is a multiple of m. And you could probably come up with some other ways of saying it yourself. I'm out, though. So now we're going to talk about congruence, another concept that we looked at back in Math 225. So let a, b, and n be integers. Congruence, I like to think of it, the concrete model that I like to use when I'm thinking about congruence is days of the week. So if I'm say that a is congruent to b mod n, what that means is if we have a calendar in which there are n days in a week, then if we look a days in the future and b days in the future, we may not get the exact same day, but we'll get the same day of the week. They'll either both be like a Monday or both be a Wednesday, maybe not the same Monday or Wednesday, but they'll both be the same day of the week. And when we let n equal to 7, because we have 7 days in the week, that's exactly what we get for our ordinary calendar. So here's an example to help us show how to use this model. We're going to show that 4 is congruent to 28 mod 3. So in this case, we're looking 4 days into the future, we're looking 28 days into the future, and we have weeks that have only 3 days. So between 4 days in the future and 28 days in the future, there are 24 days. And we can look at that in a variety of ways. Probably the easiest is to note that 28 minus 4 is 24. So what does 24 days mean? Well, 24 days, there are 3 days in the week, so 24 days is exactly 8 weeks. And so that means there are exactly 8 weeks between 4 and 28. Since we have a whole number of weeks, that means that 4 and 28 are on the same day of the week. Next, we're going to show that negative 5 is not congruent to 14 mod 5. So now I want you to note that there are 19 days between negative 5 and 14. We can do that same subtraction trick, 14 minus negative 5, or you can think of it as, well, negative 5 days in the future means 5 days in the past. So to get from negative 5 to 14, you have to go negative 5 days in the future of that just to get to the present. and then 14 more days to get to 14. So 5 plus 14 gives us 19. That means there are 19 days between negative 5 and 14. The mod 5 says that there are 5 days in a week. And so that means, well, let's look at how many weeks there are between negative 5 and 14. 3 weeks is 15 days, which is not enough, right? There are 19 days in between them, so 15 days is not enough. But if we go one more week to 4 weeks, that gives us 20 days, which is too much. So 3 weeks is too few, 4 weeks is too many. That means 19 days is strictly between 3 and 4 weeks, which means that negative 5 and 14 are on different days of the week, and that tells us that negative 5 is not congruent to 14 mod 5. So let's see if we can use this model, use this way of thinking about congruence to give us a precise definition for what it means for A to be congruent to B mod n. Well, if A is congruent to B mod n, that means we have n days in a week, and then there are some whole number, some integer number of weeks between A and B. Right? And let's let k be the number of weeks between A and B. And again, k is going to be a whole number. So I'm going to think of it in a couple of cases just to make this a little bit easier to understand. But it turns out the formulas work in the same way in both cases. So the first case I'm going to look at is A is the bigger number between A and B. So A is a bigger number, B is a smaller number. And if that is the case, if we want to find out what the relationship is between A and B, well, A is the bigger number, so we're going to take A equal to B. Well, they may not be equal because A is going to be bigger. So we've got to add the number of weeks to B to make it larger so that it's equal to A. So k weeks means k times n days. So we take that B days in the future, add the k times n days in the future, and that will give us the A days in the future. Which makes sense, right? A is the bigger number. There are k weeks between A and B. We take B, we add that k weeks to get to A. Now, if we wanted to, we could actually solve for B in that equation. We'll see why we want to do that in a moment. And we end up with B equals A plus negative k times n. Now, if B is the bigger number, well, let's see what's happening there. Well, it's going to be the exact same reasoning, except B is equal to A, except since A is smaller, it's k weeks behind, we've got to add those k weeks, that's k n days, to get from A to B. So B is equal to A plus k times n. And just as before, if we wanted to solve for A, we get A equals B plus negative k times n. And if you're looking at those two lines, they look very similar. The only difference is they're exactly the same, except the k's and the negative k's are reversed. But remember, k is just any whole number, which makes negative k just the negative of that whole number. Which tells us that in each of those cases, A is equal to B plus some integer times n. It was equal to k times n in the first case, negative k times n in the second case. And also B is equal to A plus some integer times n. That was negative k in the first case, and then positive k in the second case. But in any case, A being B plus an integer times n, or B equals A times integer times n, is exactly what we need to prove congruence. So that's our definition, how our definition is going to work. So again, A, B, and n are integers. We say that A is congruent to B mod n precisely when, well, actually, one of 5 things is going to happen. Right? The first one is is certainly true when A is equal to B plus n times k, where k is an integer. It is also true if B is equal to A plus n times k, where k is an integer. And note that in both of those cases, that integer could be a positive integer, it could be a negative integer, or actually, it could be 0. If it's 0, then that means A and B are on the same day. They're the exactly same number. Now, if we play with those equations, we get something a little bit different. If we take that first equation and subtract b from both sides, we get a minus b equals nk. That's exactly what it means for n to divide evenly into a minus b. If we take the second equation, right, and so again, that follows from the fact that a minus b is equal to n times k. We can do the same thing with the second equation, and we end up with n divides evenly into b minus a. We just take that second equation, subtract a from both sides, and we get b minus a equals nk. It's exactly what it means for n to divide evenly into b minus a. And then the last one, and this one may not be totally obvious, but it is certainly something that you looked at back in Math 225. If you divide a and b by n, if you divide each of those two numbers individually by n, look at their remainders, when they have the same remainder, that is when they're congruent mod n. And if we want to say this in terms of the mod operator, that says that a mod n and b mod n are exactly the same number. So a mod n is equal to b mod n. All right, so now I think you're ready to look at some of the in-class activities. It's called Divisibility on Congruence, and it's included with this video.